Hi everyone and welcome back to Edge-CGI. My name is Eugene Shmirov, and in this tutorial we're going to take a look at how to use Arnold renderer in Maya, and we'll be building a human eye, we'll be creating the geometry, we'll be UVing the guy, and then we'll be building our shading network. Now Arnold renderer is pretty powerful and yet easy to use rendering engine that has been gaining a lot of popularity, so I encourage you, if you have access to it, to try it. I'll kind of try and give you a brief introduction to it. Okay, so before we start, let's take a look at the anatomy of the eye based on this picture I got from Wikipedia. As you can see, the eye is basically ball-shaped with a little bit of bulge here and iris inside. Now, for obvious reasons, we're not going to be modeling all the inside parts of the eye, because we're not going to be able to see them. Now, sclera is this sort of white part of the eye, where the cornea, this bulge, is a transparent, refractive, sort of lens-like thing. And then we have the iris, which is shaped like a dish with a little bit of hole in the center, but we're not going to be modeling that hole. We're going to cheat a bit, because if we had a hole here, since we're going to be using a subsurface scattering material here on this sclera, we'll be able to, in that case, we'll be able to see through this all the red scattered light, and the pupil will appear red. We don't need that. We need it to be black, so we're going to fill this hole and apply a black material on top of it. Alright, so now with this sorted out, let's start modeling our eye. Okay, here we are in Maya interface. Let's start with creating a polygon sphere. I'm here in the polygons shelf. Just click the sphere button here and you can see the sphere appears on the screen right away. Now, I'm not going to worry about the scale for now, but what I want to do is change subdivisions. Now we have 20, and that's a bit too much. So let's change it to 16. It will be just easier to work with, less polygons for modeling and UVing. So I'm going to press E on my keyboard to enable rotate tool, and then while pressing down J, I'm going to drag along these axes. And J enables a discrete rotate, which basically angularly snaps, and this enables me to get perfect 90 degrees, as you can see here, or you can just type 90 degrees here if you prefer it that way. So let's define how big our iris is going to be. I'm going into front view here, and from reference pictures I've seen online, the iris size is approximately, it's sort of like this big. So I'm going into edge mode here, and I'm going to press down shift and then right click and select insert edge loop tool here. So I'm just going to click and insert our edge loop here approximately. It doesn't have to be perfect, just about here. Now let's go into right view and start creating the bulge. Let's go into vertex mode and translate these vertices forward. Translate these vertices here, and then select these guys. So get this vertex here. Alright, so let's take a look at it in perspective view. Now we're going to be subdividing this object. Right now it's a bit too blocky and low poly, so what we're going to be doing is pressing 3 on our keyboard, and as you can see, it turns all soft and smooth now. This is Maya's subdivision system, and this is how we're going to render it eventually. But a couple of things I want to kind of do here. First, let's get rid of the grid here to kind of see it better. As you can see, we have this sort of like pinching pole that we cannot get rid of completely, but we can tone down the pinching effect a little bit, because this flat sort of pole is okay. I mean, we're going to be applying a refractive material anyway, but these I'm not sure if you can see them, but they're here, like these rays here. This is what we need to get rid of. Now, this happens because all the edge loops kind of converge in this pole of the sphere. So the way to get rid of them is we can turn these triangles into quads. So but this will disrupt edge flow a little bit, but it's not such big of a deal. So let's select every other edge loop here. Excuse me, every other edge. And then don't press delete on your keyboard, but instead go to Edit Mesh, Delete Edge Vertex. Okay, so now we have it sort of like this, and you can see the effect got toned down. We still are getting some of those barely noticeable, but we still get those rays. So I'm going to just move this. Oops, move this vertex a little bit out here. And now the effect is a bit toned down. We're still getting this flat sort of pole, but it's not as noticeable. We'll be able to cover it up. Okay, so since we have this, well, basically, let's see. Well, it's a bit more. It's a bit too much kind of pointy, so let's maybe move it back in here. Oh, okay. Well, looks alright. It looks alright to me. So now, since we have this, basically have this kind of dealt with, it's not, you know, it's just not such a complex of a shape. Let's create an iris. I'm going to, if you're in Windows, press Control D, or if you're in Mac, press Command D to duplicate the model. And we now have two exactly the same models sitting on top of another. And to navigate through them, I'm going to enable outliner here. So you can see we have P-sphere 1 and P-sphere 2. Let's hide one of them by selecting it and then pressing Control H on your keyboard. And we have this P-sphere 2 that will turn into iris now. So this is the status for our iris as we've defined earlier. I've selected these faces. Now I'm going to invert the selection and delete the faces here. So this is our iris, and what I want to do now is I want to select, it's this shaped, right? And it has to kind of go in. So I'm selecting these edges here, and I'm just moving them in here. Let's drop out of the smooth mode. Just select these guys, create this dish shape. Now select this vertex and kind of move it inside. Okay, so we need another edge loop here because I want this hole to be a little bit more flat, and we could try and insert edge loop here, but as you can see, since we have our edge flow disrupted, this is what's going to happen. It's not doing it as we want because it kind of sees this edge ring is highlighted it for us. It kind of sees it going like this V shape. So what we want to do instead. So let's get rid of the selection here real quick. What we want to do instead, we want to select these edges in the center and then shift right click and select connect components instead. Now these edges got connected with this new edge loop. Now what I want to do is I want to double click this edge loop to select it through and then just scale it up a bit. Let's go into subdivision mode and see. Alright, so I want this hole a little bit more defined. So what I'm going to do is I'm going to select all these edges here and connect them again. And now with this new supporting edge loop, let's see. Now we have the iris a little bit more defined, and I can just move these faces a little bit more in there. Alright, so basically that's all to the iris modeling. Now, as you can see, since we had originally made this out of the sphere, we have our pivot offset. So in order to get it back to the center of the object, we're going into Modify menu, Center Pivot, and it's just going to snap it to the center of the bounding box. Alright, now let's see in our outliner, we have the sphere, P-sphere 2, which we'll rename into iris now, and the hidden one that is grayed out, we'll call it sclera. Let's unhide it by selecting it in outliner and then pressing Shift H on your keyboard. And then if we go into wireframe mode by pressing 4 on our keyboard, we can see that our iris kind of sits nicely where the bulge starts. Alright, so now that we have our modeling part done with, we can start UVing. Now we have two objects here. We'll be using two distinct different methods of UVing, and I want to start with sclera with this one. So I'm hiding the iris. Let's drop out of the X-ray here. So for those of you unfamiliar, here's a quick intro to UVing. So UVing is basically a unwrapping of a 3D object onto a 2D plane in order to position and map our textures to specific parts of our model. So if, say we had a alpha mask here, we need to UV accordingly. Now this guy, I want to UV, I want to sort of like have two UV islands here with the seam here. Now seams are important because you cannot UV without a seam in some place. Think about it as sort of like skinning or pelting that animal. You have to cut through the viewer, through the skin, in order to pull sides apart, right? So usually these seams are placed along the surface of an object, but we'll be doing it across here because I want to have these two parts as separate, as separate UV islands. With a spherical object like this, it makes sense. So, excuse me here for a sec, something's going on. So we're going to start with going here up here into UV menu, and here's the planar projection that we're going to be using. Now we need not we shouldn't click this planar, but instead click this box here. I want to be projecting from this axis. This is Z axis, so I need to make sure that I have Z axis enabled here. So if I click apply, you can see that we have our projection plane appearing here. And now if we go into our UV editor here, it's found in Windows UV editor within Maya. You can see that everything from here to here gets squashed sort of like into a single plane. Now we have some of overlapping, and we'll deal with it. So first let's put a seam here. So let's double click this edge to select the edge loop all the way across. Now as you can see, it is selected both in viewport and in UV editor, which is convenient. And now here in UV editor with this selected, I'm going to shift right click, cut UVs. Alright, but we are unable to see our cut, so before we do that, we need to press this button to toggle the visualization of the cuts. And the other thing is we need to press shaded UV display. This will allow us to see all the overlaps if we encounter some. So let's move these guys apart. Now let's see, this is blue and this is red. Basically this means that this is inverted. So before we proceed, let's flip it, go into polygons menu, flip, and everything is nice and blue now. It's actually, for this is not important, but it's in this case, but it's a good habit to sort of like have everything appear blue because it's, it indicates that it's not flipped. Anyway, so we have like a little bit of pinching here and like squashed polygons, squashed UVs, so we need to deal with it. So I'm going to select all these UVs, and then I'm going into polygon menu, unfold, and I'm going to click this box once more, not the unfold itself. Now let's check our settings. Now for this kind of unwrapping, settings do not matter as much, but I'll set it to 0.20 here. Now the spinning part is more important than this in this case. Now we don't need pin UVs, but we need pin UV border. And what it's going to do is going to relax everything inside here and sort of make it more uniform, but keep the borders intact. This is exactly what we need. So if we hit apply, you can see everything is just more uniform and relaxed. concentric, going from the center out to the border, but the border itself is intact. Now what we want to do is we want to do the same with this side here. So I'm going to go to polygons, and this time I can just press and fold because all the settings that we have punched in there are going to carry over. So with press and fold, now we have sort of matching UVs nicely unfolded for us. Okay, so now if we select everything here and go to polygons and click layout, it's going to lay out it for us here. But what I want to do is I want to, you can see it sort of like touches borders here. I don't want to do that just in case you know, it's a good idea not to have them touch the borders. So I'm just going to move them here just a bit and do the same with this one. Make sure they do not touch each other and they do not touch borders. Let's see, they do not touch each other, they do not touch borders, so everything is just fine. Okay, so basically that's it. We have our UVs for our eyeball, and we'll be creating a texture a bit later. But for the iris, let's hide the sclera now and unhide the iris by selecting it and pressing Shift H on the keyboard. Okay, so for the iris, I already have the texture. So what I want to do is I want to apply it first. So I'm going to hyperhshade. Now, in case you don't have a, if you don't have this button here, if you are on a more older version of Maya, you can go into Windows, rendering editors, and click hyperhshade here. So I'm going to create new Lambert material here, just to avoid any inconveniences. I'm going to call this one iris UV, and then call this one iris UV underscore SG, the shading group. Now I'm going to apply it. No, before that, let's first punch our texture in. So let's go and select our iris UV material, go into color, attribute, and click this checkerboard here, and click file here. Now it's created a bit of mess, but here's our file node here. So if we select this file node and then click this folder here, I'm going to navigate to my texture. So here's my texture that I'm going to use. Click open here. And now this texture is in the color channel of our material. Now let's select our iris here and right click and hold the material, and then select assign material to selection. Nothing has changed, but this is because we don't have texture view enabled. Now if you press this, you can see it has a texture, but it's all messed up. This is because we do not have it UV to the texture properly. So what we want to do is we want to go to UV, planar, click this box again, make sure it's Z-axis here, okay, click apply, and as you can see, it now has projected it from this axis, and it sort of looks a lot better, but we still need to tweak it a bit. So let's go into UV editor once again. Everything's nice and blue, so we can just disable this. What we want to do is we want to map these UVs to existing texture now. Now I'm going into a subdivided mode for now because I want to kind of see where everything's going to be once subdivided. So I'm just going to scale it down, scale the UVs, not the iris itself. Just scale it down, make sure it's where it's supposed to be. Now if we take a look at our model, this edge here, let me highlight it for you. Well, this kind of edge loop, this edge loop here, is where the iris, the blackness of the iris should start. So basically, I want all these UVs here. I want them mapped to where the iris, the black of the iris is. So basically, somewhat like this. And then I want to maybe just relax these UVs a bit, just scale them down so they are sort of just a bit more uniform. Let's see. Well, everything looks quite nice. Might want to relax some of these guys. I'm not really sure. No, let's not do that. And well, for the most part, that's all we need to do. Okay, so now before we proceed, I want to go and review some textures that I got. Now we've already seen iris texture that I had in advance, and I have also prepared this sclera texture based on the UVs that we've generated. Now I've skipped this part because we don't have much time, and because strictly speaking this is not a texturing tutorial. But nevertheless, I just grabbed our sclera sphere. I exported that with the UVs generated, put it into ZBrush and just painted on top of that, and then export the texture. So this is the texture that I got from ZBrush. Notice that I put this black dot here just in case, just to make play it safe. It might not come in handy, but basically it might affect how two materials blend when we use alpha mask here. So alpha mask has just a black dot in the same spot there, and basically that's it. We're not using any other textures. Okay, so here we are back in Maya. Let's start with enabling. Let's start with going into render settings and enabling our Arnold render here. And then we'll go to Arnold render tab and go down to gamma correction here and set everything to 1 here. We want to be working in linear color space. So I want to create a couple of lights here. Just a standard Arnold light. I want to kind of move it up here, rotate it, just to get some specular here, and make sure its intensity is 5. And then create Skydome light and load some HDRI map in there that I got from SIBL archive. It's a great resource. I'll put the link into the description. It has a bunch of free HDRI maps for you to use. So here I've loaded that. Let's tone the intensity down a bit. 0.5 will work well. Okay, so now let's start creating our shaders, and I want to go into hyperhshade here. If you don't have this button, go into Windows, Rendering Editors, hyperhshade, and I want to create Arnold shader here. AI standard, there it is. So if it doesn't appear here, it probably appeared somewhere here. So you can just grab it and graph network. It's a bit of bug here, so we'll need to assign it, and as soon as we do, it will appear here. So let's select assign material to viewport. There it is. I'll call this one sclera shader, and we'll need a couple of more. We'll also be needing cornea shader, and iris shader here. Call it iris shader. Now, I've tried several different things to kind of figure out how to mix between a subsurface scattering, whitish vein kind of part of the eye and the almost entirely transparent cornea within one single object. I've tried several different things, and I found out that the one that works the best is through color blend. So if we go to click Maya here and then just start typing color, there's blend colors node. So I'm going to middle mouse drag it here. And what it does is just kind of mixes two output colors of our shaders, and based on this sort of like slider here. But this slider can be a texture driven as well, so this is exactly what we need. But now this will need to output it somewhere, so I'll just use surface shader for that. What it does is just like it takes the input color and applies it to a material as is. So let me just assign this one. Where is this? There it is. Assign it to selection, and this output I'm just going to put it here. So let's see. Now we have this blended color from these two colors here. Alright, so what we want to be doing is we want to make sure that color 1 is everything here and color 2 is just cornea. So in order to do that, we need something to drive this blender value here. I'm going to load file node here and put our alpha mask in this file node, and then click this white circle here and out color R, connect it to Blender. Now let's see. Well, in viewport already we can see that it sort of works. Now color 2 is blue, color 1 is red. So all that is red is going, so everything that we punch into this color 1, all the outputs of these shaders will be here, and all the outputs of the shader that we put here will be here. Pretty convenient. So let's see, we have sclera here, right? So sclera, we'll first start with loading a couple of files here. Where is it? Where's our file node? There it is. It kind of does it sometimes, I don't know why. And we need to gamma correct this one. So let's type in gamma, middle mouse drag it here, select out color here, and then middle mouse drag it here. So now this gamma correct node is here to compensate for the nonlinear gamma of this file. So I'm going to put 0.454 on all 3 channels, and this is an inverse gamma related to 2.2. It's just a number you memorize. So 0.4.4 is inverse gamma relative to 2.2. So it compensates for that and linearizes it. Now let's put our texture here, and it should be applied to the to where the red is. Oh no, it's not. It's not going to be applied. Here's why. Because we don't have it connected to color 1. So out color, we connect to color 1. Give it a test render. There we go. Great. Now cornea. Okay, so with cornea we'll be tinkering with these material sliders right away. So then we go back to sclera and tinker with some of those. So cornea will have no diffuse, will have specular, pretty big specular, some roughness here. We'll use Fresnel, and in refraction tab it will be fully refractive. It will have IOR of 1.37. I found that somewhere online. This is pretty specific. Every material has its own IOR, which stands for index of refraction. And I'm going to click this Fresnel use IOR here. So now I'm going to put out color to color 2, and before we give it a test render, I'm going to select the sclera in attribute editor in shape node. I'm going to find Arnold tab and uncheck opaque. So let's give it a quick test rendering. There we go. So we have it mixed up pretty nicely. Now let's zoom in a bit and see what we need to tweak. Now the cool thing that is available in Arnold render is IPR, which is really fast, and we can enable this and start tweaking the materials, and we'll see the changes right away. So I want to tweak this cornea shader here, and I think specular roughness is a bit too high, so put it to 0.124 seems nice. So after that I'm going to replicate some of these in our sclera shader. Okay, so now sclera shader. We've already have the diffuse, and I'm going to move it all the weight slider all the way to the right. Then specular. I want a bit more specular to this. Kind of want to kind of match it with what we have in cornea here. It seems pretty nice, but I also need Fresnel here, so I might want to have more weight here and more roughness. And I'll set it to 0.1. It's not necessary to connect this to IOR because we're not using any refraction here, but roughness might be a bit too big. Okay, now let's see. A couple of other things that we need to take care of is the eye is a tissue that transmits light, so there has got to be some sort of translucency to it, right? So what we're going to do is we're going to go in subsurface scattering and then just drag it, oops, wrong, drag it to the gamma correct node to color here. So we'll assign the same color that we have around here to the subsurface scattering parameter of it. Make it just a bit more radiant. Okay, anyways, most of the work is done. I mean, the hardest part is done. But I've kind of noticed that this pupil is just a bit too big. So I'm going to hide cornea now. And then I'm going to select these vertices and scale them down. So now let's work on iris. This one was going to be a lot more straightforward than the previous one. So what I'm going to do is I'm going to just grab this iris shader, right click, hold, and we can do it. Okay, right click, hold here, assign material to selection. No renderable object. Oh, okay, I forgot to select it first. So, okay, so now we can assign material to selection. Now it turns white. That's okay. Now with iris shader, I can start bringing in some file nodes here. So I'll need gamma correct node, and I'll need file node. Okay, so just as before, I connect these. I put gamma correct. I put gamma correct onto diffuse color, and I type in 0.454 in all three channels, and select our iris texture here. There we go. Okay, so now we might update our IPR here. There we go. Now, a couple of other things that we might want to tweak. So we have diffuse. We can make it darker or lighter here. I'm going to make it lighter here a bit. Now we need a bit of specularity in this. So maybe like 0.29, something like that. More roughness. A lot more roughness. 0.43 is okay. And some for now. 0.1 might actually work. So we're not using any refraction, but we'll be using some subsurface scattering, just as before. Drag gamma correct to color. Increase weight. Let's refer back to our sclera, by the way, and see the weight. Okay, so maybe something like this. Let's update our IPR here. So now it kind of transmits some of that. And I'll be using the same, this is a bit of a hack, but I'll be using the same texture for bump mapping here. So I'm going to find our bump 2D node here, and I want my output color, output red to bump value. On the other hand, we can probably no. So we'll just select one channel here and import it into bump 2D. Just we'll be getting information from only one channel, but most probably it's the red one. The red one is going to be okay. 90% of the time, you can just grab something from the red channel. So now I'm just dragging this in here, update, and you can see we have some bump here. This is a bit too much, so how about we do it at 0.5. Did it change much? I'm not sure. No, 0.25 must work best. Yeah, okay. So if something's off, we'll change it anyway here. Okay, so now we're like 99% there. One last thing. Shift H on sclera. Update our IPR. Everything seems fine, except for the fact that it doesn't have any bump mapping here. So I want to create some procedural bump map. I want to try to create some procedural bump map. Just some habit that I got from Cinema 4D. But, okay, so mine is a bit laggy here. Let's create noise here. Let's see noise. So we have this noise node, and I'm going to place it down here, and I want to play with this noise a bit. Let's start with this one. So what I'm going to do is I'm going to just give this sclera a bit of bump. So just let's see. We'll get bump 2D node here. Middle mouse drag it out. Out color R to this one, and place this bump 2D into bump mapping. Alright, let's see if it did something to us. Okay, this is too much bump. So first I want to change, there we go. So this might work. Yeah, this might work, but before we actually do that, let's put it 0.01. Okay, so it sort of looks nice. Let's try 0.005 here. Just a hint of bump. Basically, we're there. Now that we have established all our shaders, we can go out and render. So since we're using Arnold, let's just take a look at these samples here. Now the way it works, oh yeah, and before we do that, let's increase intensity of this to 10 and intensity of this to 1, just to make everything a lot more bright. So if you go into render settings here, you can, these are like Arnold renderer doesn't have too much to tweak, so basically you just tweak this sampling here. So you know, if you want less noise in SSS, you tweak this up. In refraction, if you see some noise in, say, diffuse, you just crank it up here, and then there's this camera that is kind of increases everything at the same time altogether. So now let's just increase some of our samples here. Just make everything 3 and make camera 4, for example. And set this to JPEG, output gamma 2.2, and increase resolution to say 2K square. Nah, it's not going to work. Let's go with HD 180, 1080. Okay, so we're ready to render. So after you did that, just click render and wait for the results. Alright, so this is what we have in the end. The first pass kind of turned out to be a little bit too noisy, so I went back and re-rendered it with a little bit of a higher sample rate. So if you found this tutorial introduction to Arnold Renderer informative, don't forget to share, like, and subscribe. And I hope to see you soon. Bye.